Alright, in this section here, we're going to be talking about piecewise functions. So we've talked about what a function is, and this time our function is going to be cut up into pieces, and it's just that simple. Also, they may call these branch functions, but I'm just going to call it piecewise functions, piecewise defined functions. So of course we get started here. Woo, that's a terrible graph. Let's try redrawing. Try to redraw that a little bit better. Whoa, I'm not sure if that was any better or not. This is what a piecewise function looks like. So let's say that part of our function does this. I'm going to put an open circle right here. And then let's say that the rest of our function does something like that. Okay? And that's going on that direction and coming from that direction. So that's a piecewise function. What would not be a function is if I filled in this dot right here. Okay, so if I were to fill in this dot, then that basically means that we'll label this 2. That means that when I plug in f of 2 into our function, we would get out, we'll say that's 2, and we'll say that that's 3.5 or something like that. This right here. You know, we would get out 2, and we plugged in f of 2, we'd get out 3.5 also, and that's not a function, remember? Because remember, in a function, let me just write both these ordered pairs here. So that would be 2 and 3.5. So remember, in a function, these guys can't be the first coordinates in this relation. If it's going to be a function, you can't have two ordered pairs with the same first coordinates. Okay, then that's not a function. So we got to have a hole. There's a hole right here, or a hole here. Either one. All right, let's actually work an example now. I'm going to define my piecewise function f of x to be equal to, and this is how we would do it. Put a big curly bracket here, and we're going to do this, and the domain for this part of the function is x is greater than 0, and the domain would be x is less than or equal to 0 here. So let's graph this. So you see the function's in two pieces, okay? So this part up here, this is just a constant. So this is like writing f of x is equal to 1, except we define our domain to be x is greater than 0. Alright, so we graph this piece here. So that's just, we'll say this is 1 here, and x is greater than 0, so I need to put a hole right here because we don't include 0, and then it's just a constant. You see, going straight across at 1. Okay, so no matter what I plug in for x, it's still going to be 1 out. Now let's graph this one here. We'll say that down here is negative 1, and of course this includes 0. You see the equal sign here? This includes less than or equal to 0. So I'm going to put a solid dot, and that would be everything going off in this direction here. So any of the negative numbers I can plug into this guy here. So let's say that I wrote it like this. Alright, this, you know, writing this to describing this graph up here is, there's a better way of doing this, and that is we just write it like this. You see this? We just write it just like this right here. Big curly bracket, and then we put in each one of our separate parts of our function here, our pieces. So these are called our pieces here. Alright, so it's really just that simple. Okay, so let's look at another one. Alright, so we're going to define, you know, and I'm always calling my function f. You can call it anything you want. Alright, and x is greater than or equal to 0 here, and we'll let this just be 0 with x is less than 0. So you try graphing this out and then come back and see if it's the same thing I got.